Hi, I'm Randy Johnson. Welcome to CNC Learn and Build. Today I'm going to show you how I use my CNC to create a series of chair parts based on this antique chair back. I've been a woodworker my entire life, and I got started in CNC about 20 years ago. Back then, learning the software was a big challenge. But today, there are a lot of videos and other materials available to help you learn the software and how to operate your machine. In fact, CNC training is a big part of what I do. So if you're just getting started with CNC, check out the links in the description below. Of course, another big hurdle with getting started in CNC is the cost of the equipment. But if you're in the business of making a lot of parts, simple or complex, you'll find that it won't take long for the CNC to pay for itself. Plus, if you're a woodworker, you know how challenging it would be to recreate this part by hand or even with some jigging. But that's where the CNC really saves time and simplifies difficult jobs. I have about 4 hours of CNC time into each of these chair backs, plus some upfront design time. Now that's not a small amount of time, but a lot of it was spent just letting the CNC run while I worked on other projects in my shop. And check out this surface. With a light sanding, it'll be ready for finishing. Another big time saver. Plus, whether I make a dozen or 1,000 of these, the quality of machining time is going to be the same for each one. Now, someone still has to build these chairs, but without the time saved on these chair backs, it's unlikely this chair project would have even gotten off the drawing board. The specs for this chair back called for it to be carved on both sides rather than just the front like the original. It also called for it to be curved rather than flat. Now, it's always a good idea to check your settings before you run your actual material. So for this one, I used some glued up MDF. And I did discover a couple tool paths that weren't running the way I wanted them to, so I made some corrections before running my final material. Like most things, there are many ways to get the job done. And this is especially true of CNC. So what you'll see in this video are some of the techniques that I used to machine this first set of chair backs. There are some things I plan to change the next time around, but overall the first run was a success. I've had this Grizzly CNC for a couple of years, and I mostly use it for machining small parts and hardwoods and plastics. For its size, I can push it pretty hard, and it does a nice job of maintaining cutting tolerances. For most of my work on this machine, I use a small spoil board about the size of my project. But for this project, I added a spoil board to the entire table. In preparation for the spoil board, I decided to surface the PVC deck planks. Surfacing the planks was kind of optional, since I usually surface my MDF spoil boards anyway. But I saw it as a chance to improve the surface of the table, and since the PVC planks were only off by about 1/100 of an inch from corner to corner on the table, I only needed to take a light pass to make the table coplanar with the bit. For my design work, I used Aspire from Vectric. Vectric has a few different CNC design software packages, and Aspire is their top option. So if you want to design custom carvings like this chair back, then Aspire is a good choice. But if you're just starting out, I suggest you consider their VCarve Pro package instead, since you can always upgrade to Aspire later. One of the advantages of designing a part on your computer is that once you have your design, you can run on your CNC as many times as you want, now or in the future. I started designing this project by importing a photo of the original chair back into Aspire. I then used the photo as a guide. I started on the left side and then mirrored that to the right side. I then did some custom shaping where the parts overlapped in the middle and adjusted some of the other parts until I got the look I wanted. Once this side was done, I copied it to the other side and added the curve and some tabs to hold the part in place while machining. With the design work done, I focused on setting up the toolpaths. I was fairly aggressive with my toolpath settings since I wanted to save as much time as possible. And since I was setting up a 4-part production run, I also needed a way to align the 4 parts to the table. I accomplished this with a series of engraved lines. I then added my parts and held them in place with hot melt glue. If I were making hundreds of these chair parts, I would use some type of quick clamp fixture. But since I was only doing a dozen, I wanted something simpler, and the hot melt glue proved to be a great solution for this setup. For the 3D roughing toolpath, I combined a Z-level roughing toolpath followed by a full depth 3D raster roughing toolpath. My goal with the Z-level roughing toolpath was to remove as much material as fast as possible, followed by the 3D raster toolpath to remove the ridges in preparation for the 3D finishing toolpath. I don't usually double up on the roughing toolpaths like this, but I was concerned that the ridges left by my aggressive Z-level roughing toolpath might break off and collide with my 1/8" ball nose finishing bit and break it. The 3D raster toolpath added about 8 minutes, but I saved that time with my aggressive Z-level toolpath setting, so I considered it a net gain in the end. I also added registration holes to this group of toolpaths. These holes will be used to precisely align the boards when I flip them over for side 2. But I also needed toolpaths for side 1 to be roughly aligned and centered on each board. So to accomplish this, I programmed a separate XY0 start point for each board on the pendant. The pendant remembers these locations even if the machine is shut off and restarted, so it's a great way to set up projects or jig locations on the table. Notice how the pendant reads 2X0 and 2Y0. That's because it's at the XY0 location for position 2, which is also the XY0 location for my second part. To move to the next board, I simply press the menu button plus the number 3 key and then OK. This advances the spindle to the XY0 location for part 3. To run the roughing toolpath at this location, I open the file on the USB drive and press OK. This pendant also has an array toolpath function, which should have allowed me to run the parts automatically in sequence. But the function had a bug in it, so I was not able to use it for this project. But I also considered this first run as a bit of a test, so running each board separately gave me another chance to check my work. For the next run, I'll combine the toolpath files with a little custom G coding so they automatically run in sequence. Once the 4 parts were roughed out, I used the pendant to move the spindle back to position 1. When I ran my MDF test part, I used a long 1/8 inch ball nose bit. But for the final parts, I wanted to use a shorter bit, mostly to reduce the chances of chatter and breakage. Plus, most of the carving of this project only uses the tip of the ball nose bit anyway, so the long bit seemed like overkill. But I had overlooked that the short bit would cause the collet to collide with the project in the deep areas. Fortunately, I caught this before running the file. I still wanted to use the short bit, so to solve the problem, I added a clearance rabbet in the problem areas. The clearance rabbet did the trick, and running the finishing tool path with the short bit was now straightforward. Adding the V-carve details was the final tool path for side 1. I often add this kind of detail with my hand carving tools, but for this project I used a 60-degree V-bit and I was happy with the result. Removing the parts was actually pretty simple. A little pressure from my chisel and they popped right off. The hot melt glue only lifted a little fuzz off the MDF, a nice benefit compared with the marks left by screws, which I use a lot on my other machine. In preparation for side 2, I added registration holes to the spoil board that matched the location spacing of the registration holes on side 1. Vertical edges on 3D models from Aspire often carve rough. It's the nature of how the 3D model is created. There are various ways to minimize or eliminate this problem, but for this setup I opted to add a simple trimming pass around the edges with a straight bit. In the next set of chair backs, I plan to add some draft to the model, which should machine smoother and give me a little more material if I decide to trim it away. I still find it mesmerizing to watch the machine operate, especially knowing how much time I'm saving on this project, and also considering how little floor space this machine takes up. So if you're looking to get into CNC, there certainly are some things to consider. Price, time, learning curve. But most people find more ways to use their CNC than they ever imagined. I know I have.